Good evening, students. We already discussed about the phi equation and theta equation. It is similar like the DG rotator. The new thing is that we have to find out the radial wave equation. What is the solution of the radial equation? We know that what is the solution. The radial equation, it is the solution of theta phi 1 by r square dou by dou r square dou r by dou r. We have to write this one. We have to write that what is the solution of radial equation. What is the solution of radial equation. We already discussed about solution of theta equation and solution of phi equation, similar like that of DG rotator. We have to define the radial equation. It is similar like the simple linear harmonic oscillator, where we discuss asymptotic behavior and also asymptotic behavior, and then other cases we have to find out what is the solution, recursion formula using, just like in the simple linear harmonic oscillator. First we have to apply asymptotic behavior, then we have to apply recursion formula, then we have to see that what is the correct formula, then we have to find out C. Okay, value of radial wave equation, R value. So radial equation is 1 by r square dou by dou r. I write the radial equation 1 by r square dou by dou r, 1 by r square dou by dou r, r square 1 by r square dou by dou r square dou r by dou r by dou r plus 8 pi r square mu by h r square, 8 pi r square mu by h r square mu by h r square whole r bracket e minus vr bracket n minus beta r by r square minus beta r by r square is equal to 0. This is called the radial equation we derived, and we have to find out what is the solution of this equation. What we do, we take the derivative of this 1 by r square, derivative of, I make it common 1 by r square, derivative of, we take r square as similar, derivative of this dou square r by dou r square plus what we take then take the derivative of this dou r by dou r, derivative of r, this just is a product uv dou by dou r of r square, then bracket n plus 8 pi r square mu by h r square whole of r bracket e minus v r bracket n minus beta r by r square is equal to 0. Then we have to multiply this 1 by r square with this equation. R square cancel. Then what is remaining? Dou square r by dou r square plus, here is derivative of r square, 2r, here is r square, 1r is cancelled, then 2 by r dou r by dou r, because this is derivative is 2r, this one is 2r into 1 by r square, 1r is cancelled, 2 by r remaining, then this is remaining. So dou r by dou r plus 8 pi square mu by h square. Take these are both sides. So take r common from both the side. No, you have to keep it. I already written. Okay, you have to multiply with this all thing. Then we have to take common. This is multiply with this is equal to r e. Then this is multiplied minus 8 pi square mu by h square r vr minus beta r by r square is equal to 0. That means this is multiplied with this one. 8 pi square mu by h square r 8 this one 8 pi square mu by h square r e a minus 8 pi square mu by h square r vr minus beta r by r square. Beta r by r square. So then what we do, this vr that we know vr is equal to minus z square by r. Vr already we described. Here z is the atomic number 1 because we take the hydrogen atom. Atomic number is 1. So Vr is equal to minus e square by r. So Vr is equal to what? Now minus e square by r. We substitute this value here. Okay. Then what we get? Now here also you take this one is alpha. This one is alpha 8 pi square mu by h square e is considered as alpha. Alpha is equal to by alpha square you take alpha square is equal to minus 8 pi square mu by h square e. This is called alpha square. 8 pi square mu by h square whole e. This is called alpha except r. Then if I substitute this value, what we get? Dou rho square r by dou r square plus 2 by r dou r by dou r plus here 8 pi square mu by h square e is considered as alpha square, means minus it is minus alpha square r minus 8 pi square mu by 8 pi square mu by h square r. In place of here I write minus e square, so minus minus plus e square by r minus beta r by r square is equal to 0. Then what happens? We take r common from these three. We take the r common. Next page I have to write in this way dou r square r by dou r square I have to write. What is the value? Dou r square r by dou r square, dou r square r by dou r square plus 2 by r dou r by dou r by dou r. Then what we do? Now we have to take r common from the last three. From that means here you have to see these three, you have to take r common. If you take r common, what you get? R common, what you get? Minus alpha square then 8 pi square mu minus or plus 8 pi square mu plus 8 pi square mu by h square e square by r, e rho square by r. We take capital R common, minus beta by r square. We take capital R common in all cases. Okay. Now you take another, this one, we take this one is equal to lambda. Let lambda is equal to 4 pi rho square mu e rho square divided by h rho square. I take this is alpha. So this we take lambda. So we take this alpha to this side. So lambda alpha is equal to 4 pi rho square mu e rho square by h rho square. That means here you take 2 alpha, 2 lambda. This is the, I can, in place of 8 we can write 2 into 4. The 2 into 4 is 4 pi rho square mu e rho square by h rho square. This one is equal to lambda alpha. Then 2 lambda alpha, substituting this value, dou rho square r by dou r square plus 2 by r dou r by dou r plus bracket minus alpha square plus this one will be 2 lambda alpha by r, 2 lambda alpha by r. This one is remain same, beta by r square bracket n whole r is equal to 0. This thing we have to know. Then we have to convert it into x. Let we have to convert it just like whatever we did in simple harmonic motion, same thing we have to proceed. 2 alpha r. We need what? Now dou r by dou r. So dou r by dou r, I can write it as dou r by dou x into dou x by dou r. Okay, dou x cancel, dou r by dou r. Then we have to put it here. Dou r by dou r is equal to, what we get here? Dou r by dou r by dou x, that is no change. You take dou x by dou r of this equation. Dou x by dou r is equal to 2 alpha. Then we have to substitute this value dou r by dou r here, and this value is there. We have to convert it into x. We have to take second derivative of it. Second derivative, dou r square r by dou r square, which is equal to dou by dou r into dou r by dou r. This one is equal to this one. This value I know, dou by dou r. This one is dou r by dou x into 2 alpha. That we know. This dou by dou r, this dou by dou r is equal to this one, dou by dou x. We have to make convert it. Then dou r by dou x 2 alpha bracket n, we can write dou x by dou r. Then what is its value? Now this value is dou by dou x. It is remain as same, dou r by dou x dot 2 alpha dou x by dou r. Dou x by this value, dou x by dou r is equal to 2 alpha. Okay, what we get? Now we have to get dou square r by dou r square. This one 2 alpha 4 alpha square dou r by dou x. Dou r by dou x, ये dou by dou x, then dou square by dou s square. Then we substitute this value and this value in this equation. Then what we get? In this equation we have to substitute this one, 4 alpha square dou square r by dou s square plus 2 by r. In this place I have to write this one, dou r by dou x into 2 alpha, dou r by dou x, 2 by r, dou r by dou x into 2 alpha, plus whatever is remain as such, minus alpha square plus 2 lambda alpha by, I put this one, minus beta by r square whole bracket r is equal to 0. Okay, dividing the equation by 4 alpha square, because here x is alpha is, so dividing the equation by 4 alpha square, dividing this equation by 4 alpha square, then what we get? Dividing this is cancel, dou square r by dou s square. Here we have to divide this one 4 alpha by r. 4 alpha by r means we divide with 4 alpha square. 4 alpha square, then what we get here? 4 alpha square, that means is a 4 alpha by r. 4 alpha by r, dou r by dou r. Then the cartoon, what we do? We keep it this like, we have to 4 alpha by r, dou r by dou x plus common minus alpha square 2 lambda alpha by r minus beta by r square whole bracket whole is equal to 0. Then what we do? We had to convert all r into x. We have to this one I take x is equal to 2 alpha r, x is equal to 2 alpha r, so r is equal to x by 2 alpha. Then we substitute here in place of r, here this 3 with x by 2 alpha. Then what we get? Dou square by r, dou x square plus 4 alpha. In place of r I write x by 2 alpha. X by 2 alpha, 2 alpha will go up. Then what is remaining? Dou r by dou x into minus it is alpha square, alpha r only we take, this is remain as such, plus 2 lambda alpha by r. In place of r I write x by 2 alpha, 2 alpha will go up, minus beta by r square is equal to s square, here r square is equal to s square by 4 alpha square, 4 alpha square will go up, whole of bracket r is equal to 0. Then I made a mistake here, we have to not make it divide, we have to keep it as such. Then okay, 4 alpha square, here also 4 alpha square. Now we have to divide the equation by 4 alpha square. Dividing this above equation by 4 alpha square. Let this one is cancel, dou square r by dou s square plus here is 4 alpha, 4 alpha square, so 4 alpha square by 4 alpha square is cancel, remain is 2 by x dou r by dou x plus bracket by 4 alpha square. Alpha square is cancelled. Remain is minus 1 by 4. Simply plus 2 lambda 2 into 2 4 alpha into alpha 4 alpha square, it is cancelled. What is remaining? Lambda x minus 4 alpha square cancel, beta by s square whole bracket r is equal to 0. So this is the equation, final equation we get, but we have to find out what is the solution of this equation. That just like whatever we do in simple harmonic oscillator, we have to first take asymptotic behavior. That means what is it? If x tends to infinity, that means 1 by 0. Here I put 1 by 0. S is equal to 1 by 0. So 0 will go up, 0 into 2, 0, 0 by 1, 0. 0 into ethic is equal to 0. So this factor is vanished. This factor also vanished, 1 by 0. 0 by 1 is equal to 0. This factor also vanished. Then what is remaining? Now dou rho square r by dou s square minus r by 4 is equal to 0. This is remaining. And the solution of this equation, r is equal to e to the power plus minus x by 2. So there are two solutions. What are the two solutions? Now one solution is e to the power plus x by 2, or another solution e to the power minus x by 2. Here you see, it is as x tends to 0, this value will increase, but in this case this value will decrease, minus. Here this value will increase, r value will increase. So this solution is not acceptable, but this solution is acceptable because this tends to 0 as x tends towards 0. So this solution is acceptable. E to the power minus x by 2 is acceptable. So the solution, the acceptable solution, acceptable solution is r is equal to e to the power minus x by 2. Then whatever we do, we have to justify that this one is correct. Then what we do? Now recursion formula, just like whatever we did, we have to do in the similar way. Recursion formula we have to apply. Then what is the recursion formula? Now Rx, what is the value should be? Now Fx e to the power minus x by 2, where Fx is a function of x, So Fx, Rx is equal to Fx e to the power minus x by 2. Then what we did? Rx is equal to Fx, I write once again e to the power minus x by 2. So Fx is equal to what we write here. Now here in case of Fx, which is equal to x to the power L, Lx. So if you substitute this in with this equation, x to the power L, Lx e to the power minus x by 2, we have to continue this process. So what we do? We take the first derivative, we take the second derivative, whatever the value we have to put in this equation. Dou rho square r by dou s square, this is second derivative, this is first derivative, whatever the value we get, we put this value in this equation. Then we have to see that whatever we take Fx, This one is correct. Just like the simple harmonic oscillator, whatever I did, the same process we have to do. This fx we have to find out. Then what we do? Now first we do first derivative of dou rx by dou x. What we do? Now fx first derivative, this one, and I keep this one is constant. Then fx is, I take constant, and e to the power minus x by 2, then minus 1 by 2. This is the derivative. Okay, then what is the final equation? F dash x e to the power minus x by 2 minus half fx e to the power minus x by 2. Then we have to take second derivative, d rho square rx by ds rho square. What we take? Now this derivative of this equation, dou by dou x of f dash x e to the power minus, I write this one, minus 1 by 2 of fx e to the power minus x by 2. Then what we did? When you take derivative, this one we have to first take, suppose I keep this one is constant, derivative of this second derivative, then keep this one is constant, derivative of this e to the power minus x by 2 into minus half, then derivative of this minus half, suppose I keep this one is constant, derivative of this, that means f dash x again minus half, keep this one is constant, derivative of this minus x by 2 into minus half. Okay, then you have to make it second derivative of this, dou rho square rx by dou s rho square e to the power, I take this one is first, double dash x e to the power minus x by 2. Here is what we get, minus half f dash x e to the power minus x by 2, then here minus half f dash x e to the power minus x by 2, then minus minus plus, half is equal to 1 by 4 fx e to the power minus x by 2. These two things are same. Half means it will remain as 1. So this value will come as f double dash x e to the power minus x by 2. This half is equal to 1, f dash x e to the power minus x by 2 plus 1 by 4 fx e to the power minus x by 2. Now whatever we did, we substitute this value, we substitute this dr by dx, and this one and this one and this 3 we have to substitute in this equation. Okay, just like in simple harmonic oscillator, after substituting this equation, first written is second derivative, we have to write the second derivative of it. I write this one, f double dash x e to the power minus x by 2 minus f dash x e to the power minus x by 2 plus 1 by 4 fx e to the power minus x by 2. Then what is remaining? 2 by x d by dx plus 2 by x. Then we have to put this value, f dash x e to the power minus x by 2 minus half fx e to the power minus x by 2 bracket n 2 by x. Then what is remaining? Minus 1 by 4 minus bracket s 1 by 4 lambda by x plus lambda by x minus beta by s square, beta by s square. In place of r I write this one, fx e to the power minus x by 2. After simplifying this one, that means this one all double derivative in one side, this is single derivative, this is you have to get single derivative, you take this one to this side, all fx in one side. Simplifying this, same process we have to do, and then we have to see that fx is equal to x to the power s gx. We have to take first derivative, we have to take second derivative. After getting second derivative, put this value here. After getting first derivative, put this value here wherever is first derivative, and fx value here. And because we have to take this equation, first derivative is f dash x, means dou f by dou x is equal to whatever we get, now x to the power x gx, whatever is there, then gx is keeping constant of this one s x to the power s minus 1. This is called first derivative. We substitute this value in this case and this first derivative. Again we have to substitute second derivative. From this we get second derivative, and this second derivative will substitute in these cases. After the and fx whatever there, substitute this value. After substitution, you get the value, whatever you find out that polynomial equation, and we get the value of r. And this r value, same process, what is simple harmonic motion, r value you will get same process, c e to the power minus x by 2 we get from asymptotic solution, and this value x to the power l, then l n plus l 2l plus 1 whole x, and this value, that means whatever we collect, this value is correct. We have to prove this one, and after getting this RR value, we have to find out the value of C. How to find out? Now, using normalization condition, R is equal to dr. Here is remaining is r square should be equal to 1. Then what we do? Now we put this value in place of RR. I write C e to the power minus x by 2 x to the power l 2l plus 1 n plus l x dot C e to the power minus x by 2 x to the power l n plus l 2l plus 1 x. Then whatever r square, here we have to convert this into x, so it is equal to dx is equal to 1. Then cc is equal to 0 square. We have to find out the c square value. Integration e to the power minus x by 2 x to the power l n plus l 2l plus 1 e to the power minus x by 2 x to the power l n plus l 2l plus 1 x dx is equal to 1. After that, you have to find out what is the value of c. The c value you can get from this equation 2z by na0 2z by na0 ra q n minus l minus 1 the factorial divided by 2n bracket n plus l the factorial bracket n the whole cube. This is the c value, and substitute this value of c in this equation, and we get what? Na r value. Then when we substitute this value, 1 minute to over. When we substitute this value, we get what? Na r n l r. Substitute this c value. The c value is 2z by na0, 2z by na0 whole cube, because it is c square. So c square we get n minus l minus 1 factorial divided by 2n n plus l factorial whole of cube. This is to the root over, because c square is this much, then whatever is remaining we have to put e to the power minus zr by na0, then whatever is there 2zr by na0, then 2zr by na0, this one is x, we have to take to the power l, then l n plus l, 2l plus 1, in place of x we write 2zr by na0. This is called the solution of the radial equation. Same process we have to proceed whatever we did it in the simple harmonic oscillator. But you do not do all the derivation because time is running away. So you remember certain peculiar points. Suppose this point you have to remember, leave all this blank, then this one you remember, then this one is remember. Then in this case you escape all the derivations and remember this one. This is equal to c square. C square na c square. So c is equal to your root over. You remember this one. Now substitute this c value in the RR equation. This is the solution of the radial wave equation. Now time is already over. Okay. I will stop here. There is one more equation, that energy equation. After that we will move to the angular function. You skip many steps, otherwise you will not get time in the exam. Okay, thank you very much.